Okay, we're going to look at aldehydes. Now, the carbonyl group is where we have a C double bonded to an oxygen. And this comes up in aldehydes, ketones, carboxylic acids, acid chlorides, amides, and esters. So it's quite common. Actually, let's just go back to that for a sec. The oxygen is more electronegative than the carbon, which makes this a polar bond with the negative side being the oxygen side of the bond. Okay, the naming is our prefix with Al on the end. So methanal, ethanal, sorry, that should say ANAL on the end. So methanal, ethanal, propanal, and so on. We don't need to number the carbonyl group because that's always the first carbon. So when we say propanal, we mean that the numbering starts with this carbon here being the first carbon. So there's no need to name. There's no need to use a number to indicate where the carbonyl group is attached. It's basically just like a carboxylic acid, but with a without the O on the OH. So instead of COOH, it's just COH, CHO. The physical properties, both aldehydes and ketones are pretty similar. They're both polar. They don't have hydrogen bonding between the molecules, between aldehyde molecules, but they can hydrogen bond with water, which means that they are volatile. They will react readily with water and more volatile than alcohols or carboxylic acids. Small chain aldehydes are polar and therefore soluble in water. As the carbon chains get longer, the non-polar part of the molecule becomes kind of overtakes and they become insoluble in water. Aldehydes have an unpleasant smell, which is worth noting. Okay, we're going to look at preparation of aldehydes, oxidation, and reduction. Preparation, the easiest way is to take a primary alcohol, it must be a primary alcohol, and oxidize it. So in this case, we're using dichromate with an acid as a catalyst, and we get an aldehyde. Now the problem here is that an aldehyde is easily further oxidized to a carboxylic acid. So what do we do if we want to produce an aldehyde, but we don't want the further oxidation to take place and end up with a carboxylic acid? Well, there's two ways of approaching this. One way is to have an excess of the alcohol, so that when we add, and just add this a little bit at a time, so that when we add the oxidant, there's only enough of the oxidant to oxidize it to an alcohol, not enough to oxidize it further. So having an excess of the alcohol and just adding this a little bit at a time, or we can use distillation to capture the aldehyde as it is produced. So here's an example of this. Let's say that we're trying to make ethanal. We would start with ethanol in our container, our tube, and we're going to drip in a mixture of potassium dichromate, which is our oxidant, and sulfuric acid, which is our catalyst, and we're going to provide heat to the ethanol here. So what's going to happen is, as we are gradually releasing the sulfuric acid and dichromate, the aldehyde is produced. We've got an excess of alcohol and not much of the oxidant, so it only gets oxidized as far as the aldehyde. And then if you want to capture the aldehyde and separate it from the alcohol, we heat the mixture down here to the boiling point of the aldehyde, which will be lower than the boiling point of the alcohol. So the aldehyde will boil first. As it boils, the vapor comes up here, it goes into this tube here, and then we cool. We have a condensing chamber, so we cool this area here. As the aldehyde cools, it condenses back into liquid form, and we capture it down here. So that's how we can capture an aldehyde using distillation. The oxidation, so as I said before, aldehydes are further oxidized to carboxylic acids. If we're starting with ethanal, we're going to end up with ethanoic acid. So all we have to do is continue our oxidation reaction, just add more of the oxidant and the sulfuric acid as the catalyst, or whatever acid is the catalyst, and heat, and we will end up going from an aldehyde to a carboxylic acid. Aldehydes are very easy to oxidize. A common way of distinguishing between an alcohol and an aldehyde is to use a reagent called Tollens reagent. Tollens reagent is a mild oxidizing agent. It's weak, but aldehydes are easily oxidized. So a Tollens reagent will oxidize an aldehyde, but it's not strong enough to oxidize an alcohol. So it's a way that we can distinguish between an aldehyde and an alcohol. What do we have? If the substance is oxidized by Tollens reagent, and the evidence of that is that it produces a silver mirror in the test tube. Silver precipitate forms. It's actually forming silver. Then oxidation has taken place, and that means that it was an aldehyde and not an alcohol. With an alcohol, we would see no reaction. Another way is using Benedict's or Feeling solution, which is a mixture of which contains copper ions, which are a mild oxidizing agent, and we have to heat it. So if we react Benedict's or Feeling solutions with an aldehyde and we heat it, the solution will change from blue to a red brown precipitate forming in the mixture. So that's the color change that we'll see, and we wouldn't see that color change with an alcohol, because again, this is also a weak oxidizing agent. Okay, we can also reduce an aldehyde to go back to an alcohol. Okay, just as we oxidize an alcohol to go to an aldehyde, we can reduce an aldehyde to go to an alcohol. The most common way of doing that is using sodium borohydride in an alkaline solution or alkaline conditions. And we go back from an aldehyde to a primary alcohol by doing that. Yeah, so that's aldehydes.